Hello, everybody. Welcome to class. Good to see you guys. Thanks for being here, as always. Just going to give us a few minutes until it's 11:30, about 1 minute, actually, and then we'll start talking about today's meeting and a couple of items that we all want to go over. Hello. Hi, Leo. Anybody else that's here, feel free to just chime in and say a few words of greeting if you like. Good to see you guys. Hi, Kimberly, Nathaniel, Brenna, Samir, Lily, Josephine. Hope you're having a great day so far. And yeah, I'm just going to start off our lecture in just a minute. Hello, hello. Hey, everybody. Amaya, Arlene, Alexis, and all the rest. Really appreciate your guys' attendance and all of your hard work so far. We got another key meeting coming up right now, so let's just get started. Good morning, everybody. It's pretty much 11:30, so I'm going to start our lecture off and get us going. Welcome back. So let me, first of all, make sure that you guys noticed I sent off the first problem set for homework just like in the last half hour. Have any of you guys noticed it yet? Has it come through in your announcements on Titanium? Someone could just let me know. And if you have got it, then I know that it's been sent to the class. Who can tell me? Can you confirm? Or can you, I mean, it should be there, but sometimes maybe it takes about 30 minutes for them to post. Okay, Brenna sees it. So if any of you see it, it's a mass delivery system. So that means everybody did get it. Okay, good. So that is the first homework assignment. It's 20 problems. I changed the due date just slightly. Take note of that. Okay, so in the syllabus originally, it was listed as being due Monday the 14th. I just made a slight edit, and it's now due Wednesday the 16th. So it's just 2 days later than originally written. So you got 2 weeks starting today to complete those 20 questions and return your answers to me as an email attachment, anytime before class time, Wednesday the 16th. So we'll go over those topics. There's a little bit more material we're going to add today, and hopefully that puts you in good position to start tackling homework and approaching those questions there. I also sent the link for Zoom office hours for today's office hour. I always have them every Monday and Wednesday, if you remember, from 1:30 to 2:30. So if there's ever a person who would like to, swing by during my office hours, I'm happy to help out and answer any questions. Monday, of course, is a holiday because it's Labor Day. So my typical Monday office hours I won't be holding because it's a day off, but today I have them and next Wednesday. And then also anybody who's looking for some last minute perhaps help or anything else with the homework, there's the following Monday of the 14th since I moved the due date. I wanted to move the due date partially because of the fact that we have the Labor Day holiday on Monday taking one of our class meetings away. So anyways, that's just an update on our class. You've got the first homework problem set now. And we'll talk about the topics that are referred to in it. But hello to everybody. Good to see you guys showing up. And as usual, I hope your classes are going well and that your first couple weeks are smooth. Okay, so I'm just going to start now by reviewing some of the main points that we've already covered. And then I'll add a couple of new things to that. So starting off the class, what is the homework assignment? It's a set of 20 problems that you now have. You can send it as an email through Outlook, that's right, just as an attachment. Make sure to attach the file properly and I'll receive your submission. But not to worry yet, obviously you're not going to turn them in until a little closer to the due date, but that's right. Okay, so yeah, our whole class is a class in logic and logical reasoning and critical thinking. We started off by just defining the term. What is a good critical thinker? It's a sort of person that doesn't believe anything unless it's based on a good argument with good evidence. And at the same time, when they make arguments and when they make claims to others, they make sure to base those claims on good arguments and evidence. So that pushed us to then consider in more depth what the term argument actually refers to. And as maybe now you guys are getting familiar, an argument in the formal sense is just a set of two or more sentences in which one sentence is the conclusion, the claim that you're trying to prove to be true, and all the other sentences in the argument are called premises, which are the reasons or the evidence that's given to support the conclusion. When an argument's written out in standard format, you've got the conclusion at the bottom, and a horizontal line separates it from the premises, which are listed above that line. Now, we talked about how the whole point of constructing arguments and so forth is to try and persuade or convince someone or some audience that the conclusion of the argument is true. The argument serves as the presentation of reasons for the conclusion. So we're trying to show the conclusion to be true. And as we talked about truth, the concept of truth is just that a sentence is true when whatever it says corresponds to the actual facts going on in reality. After that, I think we talked about what are like some conclusion and premise indicator words. We talked about how there are words which indicate you're looking at the conclusion of a logical argument. For example, therefore, thus, hence, so, it follows that, consequently, and those types of examples. We talked about premise indicator words, words that indicate you're looking at a premise in an argument, since, because, due to the fact that, given that. Okay. Then we talked about the topic of validity and soundness. So we mentioned how an argument is deductively valid what does it take for an argument to be a deductively valid argument? What's valid? Just in case, if and only if what? Let me see if one of us can tell me that. To be valid, to be deductively valid, what must be going on with the argument? It has to be an argument where what? To be valid, to be deductively valid. There's a precise definition of this. So not possible for all premises to be true and the conclusion false, exactly. Now Amaya, I have to correct, and April also, both of those comments I have to correct. For an argument to be deductively valid, the premises don't have to actually be true. They have to be such that if they were true, then the conclusion would have to be. But that's the word if. It doesn't mean that they are actually true, because there's another concept, which is the concept of soundness. Okay? Now tell me, what does it mean when an argument is sound? What's that mean? What does it mean for an argument to be sound? Just want to see your retention on that, and then I'll talk about it more. Yeah, so Evelyn, correct. When an argument is sound, well, there's another part too, just to mention. It's got to be valid, first of all. But on top of that, all the premises are actually true. Soundness requires that all the premises are true. Validity only requires that if they were true, then the conclusion would have to be also. Okay? Let me try to provide some examples here so that you get the idea. So, all dogs can fly. That's the first premise here. Labradors are dogs. And what would be our conclusion in this case? Just so we can all say and understand what it is. All dogs can fly. Labradors are dogs. So therefore, Labradors can fly. Correct. Now let's just, this is a little review. Thank you guys. Correct. Labradors can fly would be the logical conclusion of this argument. Now tell me, what's the status of the argument in terms of all of our terminology? Is this argument, well, what kind? You tell me. This argument written on the board is valid but not sound. Exactly. It is deductively valid, but it's not sound. Now, remember when I asked you guys, what does it mean when an argument is valid? And one attempted answer was all the premises are true. But I hope you can understand by looking just at this one example that it's valid, but not all the premises are true, right? Which premise is not true here? It's premise 1, clearly, because it says all dogs can fly. So I'm just trying to help you understand something, that when an argument is valid, the premises might all be true, or there could be some that are false. That distinction has to do with soundness. Validity just has to do with whether the conclusion is a logical consequence of the statements above the line. So in this argument, it's valid on the simple basis that this conclusion follows logically from these two premises. In fact, in a formal sense, if we had an argument which just used x's and y's instead of actual names, if I say all x's are y's and A is an x, then it would follow that A is a y, regardless of what we substituted for the terms A, x, and y. So just the form of this alone is enough to demonstrate that it's valid. But the falsehood of premise 1 is what deprives it from being sound. Okay? So just, I need that to be clear to you guys. Validity by itself does not tell us whether the premises are all true or not. All the validity tells us is that it's impossible for all the premises to be true and the conclusion false. So that in case the premises were true, the conclusion in that case could not be false, right? So you have to engage in a bit of hypothetical reasoning when you judge whether an argument's valid or not. You have to imagine a situation where the premises are true, and then you have to judge whether or not this conclusion would have to be true or not in that hypothetical situation. Okay, so once again, being valid, it could be the case that some of the premises are not true. But if they are all true with a valid argument, that means the argument is sound. Okay, let me give you another example here, just to sort of drill and expand on your understanding of validity. Okay, so let's look here next. Consider this argument. Actually here, I'm going to make this argument very simple with just one premise. Okay, so the premise here just says Donald Trump is older than 35. And the conclusion I'll say is just therefore Donald Trump is the president. Okay, now question. Do you see the example? Is that a valid argument or not? The argument written says, because Donald Trump is older than 35, therefore Trump is president. Since Trump is older than 35, therefore he's president. Is that valid or not valid? Okay, no. I'm seeing people writing no, and that's correct. It's not a valid argument. Why is it not valid? Let's understand the reason why it's not valid. It's not valid, Lily. It's not valid. And why is it not valid? Because, well, just because Donald Trump is older than 35, that does not logically imply that he's the president. Though being 35 is a requirement for holding the office of president under the Constitution, it's not sufficient to be president. Otherwise, I'm older than 35. So then everyone who was older than 35 would have served as president if that implied logically that you were the president. So notice this. Are these two statements true, though? Are those two sentences true that you see? Is the premise true, and is the conclusion true? That's a new question for you. Are they both true? Yes, they are. They are both true. Now, I want you to understand something very clearly right now. Even though all the premises are true, it's not valid. So validity has to do with the logical connection between the premises and the conclusion. Does this information force this to be true? No. In other words, is there a possible world where Donald Trump attains an age above 35 and didn't become president? Surely that's possible. It's not the actual world, I guess, but it's possible that that could have happened. So this information does not logically imply this conclusion. So just understand that just because the premises are all true, that's not enough by itself for the argument to be valid. In fact, whether the argument's valid or not doesn't depend on whether the premises are true or false. You can have a valid argument where all the premises are false, some of them are true and some are false, or where all of them are true. So for you to judge whether an argument is valid, you need more information than just knowing that the premises are all true. You need to know, furthermore, whether or not those premises, whether they are true or false, contain information that logically implies the conclusion, okay? So this argument is not valid, even though the premises are true. And in the previous case, I gave you an argument that was valid, even though the premise that all dogs can fly was false. So just remember, when judging the validity of an argument, the question is this: is it even conceivable for the premise to be true and the conclusion false? If that's conceivable, in other words, possible to imagine, then that's an invalid argument. When an argument is valid, it is impossible for the premises to be true and the conclusion false. But in this case here, it certainly is possible for this to be true and for this to be false. In case, for example, Trump had not won, or in case he loses in the future. In that case, we will have the fact that he's older than 35, but false that he's the president. Being over 35 is not sole sufficient to imply that a person is an office holder of the president. Now, I guess I could make a valid argument with this conclusion, like to become president, one simply has to attain more than 270 electoral votes in the Electoral College. Trump attained more than 270, and therefore Trump is the president. That would be valid, I guess, because it states the actual requirements for winning. And the citizenship requirement, I guess. Okay, so I want to also return us to one other quick topic that we mentioned at the last point of our lecture last time. We talked about logical truth, logical falsehood, and logical indeterminacy. So who can remember, what does it mean when a sentence is logically true? What does that even mean? To be logically true, what does that entail? For a sentence to be that, what's the conditions to be logically true? A sentence is logically true when it is not possible for it to be false, exactly. So it's something that is true, which is not possible to be false. Can anyone remember or give an example of a logically true statement? Yes, that's very good, guys. Thank you. It is a sentence that's true, which could not possibly be false. What is one example of a sentence like that? Something that comes to mind. 2 + 2 is 4. Good. 4 sides on a square. Yes. So geometric, logical truths of that kind, mathematical truths and so forth, they're logically true. If I tell you that it will be rainy tomorrow, say I'm like a weather person, I can't say that that's absolutely certain. Probably it'll rain, like is the right answer, you know, maybe with 90% chance or whatever. But 2 + 2 is 4 is not like predicting the weather. It's just a matter of mathematical deductive reasoning. We'll learn more about other examples of logically true statements as we continue, but anything that says something of the form that a thing has self-identity is also logically true. So if I say that the brown dog is brown, that's logically true because it says that the object has a predicate which is stated in the way of referring to it. So if I say, you know, a square is a square, that's logically true. If I say anything having to do with math, 3 is greater than 2, if it's a mathematical true statement, then that's logically true as well. Okay, logically false is the opposite of that. Logically false sentences, as you guys, I would assume, will know, is a sentence that is false and which could not possibly be true. What is an example of a logically false sentence, if anyone can throw one out there? Logically false sentence. So it's, yeah, let's see what you have for me. Something that's logically false. 2 + 2 = 6, good. So an incorrect mathematical or geometric statement would be logically false. Rectangle having 3 sides. I'm 21 and 35. That's very good. The Earth is flat is not logically false. I think we talked about this before. Even though the Earth is a sphere, the idea of it being flat is merely regular false, not logically false. Because I guess in theory, you can imagine some kind of disc-shaped object in the cosmos that has the behavior of a planet. Dogs or reptiles, good. That's logically false. Humans are born from eggs. Karina, I mean, that's one that I guess I would not say is logically false, because although we are born in live birth as mammals, it's not inconceivable that evolution could have taken a different track some way back in the past, leading to a counterfactual timeline of history in which we are like the platypus, a mammal that still has eggs. So that's a very rare case, but it's not theoretically inconceivable. So when you think of a logical falsehood, it has to be something that's not just really, really weird and seems to be obviously false, but it's got to be something that is impossible to be true. Okay, but those are all very good examples. Cats can bark. Jasmine, I would have to say this is also not the right example, because although cats meow and dogs bark, that's just having to do with the development of the acoustics of their vocal cords and so on over time, which we can imagine in a counterfactual timeline of universe history that could have been the opposite. Okay, so good examples, and where I needed to clarify, I think I was able to do it. Okay, so logically indeterminate sentences, though. What are those? Those are the things that are not logically true nor logically false. So they're things that could be true or could be false, and it just depends on how things turn out. Can you give this? This is the most, I think, easy category for you to give an example of. But remind me one more time, what could be some logically indeterminate sentence? Anybody can throw one out. Something that's not governed by logic to be true or false. Okay, it's raining today. In fact, at least where I am, it's not raining. But that's not a matter of logic that determines that. The Earth is flat. Okay, good. The Earth being flat is false. But I guess some might argue that there's a conceivable situation in which it's true. Like I was just mentioning, the guitar has 6 strings. That's all right. You are standing. Okay, whether you're standing or not, it's something that could be true or false. So it's not always true or always false. I'm wearing red. Another fair example. If you're wearing red right now, then it's true at this time. But of course, there's circumstances in which it's false. So if there's a condition where it's true and a condition where it could be false, it's logically indeterminate. Pineapple goes on pizza. That's a controversial position, I think, for some. But at the end of the day, it can be true under some pizza topping selections, and it can be false under others. So that's indeterminate as well. Okay, good. So I like all those examples. Now, the last thing I just briefly touched on last time at the tail end was about induction. Let's remember that just for a moment. When you have an inductive argument, the argument has premises which, if they are true, then the conclusion is what? Highly likely to be true. That's different from deductive validity, because with deductive validity, if the premises were true, then the conclusion would have to be. With inductive strength, an inductively strong argument is an argument where if the premises are true, then the conclusion is probably true, but it's not necessarily certain. So what could be an example of an inductively strong argument? Did I talk to you guys about the thing having to do with the sun coming up? Did I get a chance to mention that example of the sun coming up as an example of an inductive argument? Let me know. If I have, then I'll mention it just in passing. If I haven't, then I'll go over it again. Okay, good. Yeah, so the sun coming up. That's one inductive argument. The sun has come up for billions of years. Therefore, the sun will come up tomorrow. Surely, it's reasonable to believe that it will come up tomorrow after all these years and days of it doing so in the past. But the conclusion of that argument cannot be guaranteed. So it's merely inductive rather than deductive. Okay, Lily, in your case is I woke up yesterday, so I'll wake up today. In fact, though, there's more evidence than just waking up yesterday. You've woken up every day, I assume, for at least 18 years. And therefore, with that long-term track record, it seems pretty reasonable and probable that you'll wake up tomorrow too. But just as much as the sun, or perhaps even more so, the ability of a person to continue waking up every day is certainly not something that can be known with total precision, total certainty. Let me give you other examples of inductive arguments. Let's see. Every day, Monday through Saturday, the postman delivers mail to me, and that has been happening for as long as I've been alive and have had an address. So today is Wednesday, therefore the mailman will deliver the mail today. Is that probable? Yes. And I have a lot of track record evidence going back in time to base the conclusion on. But who knows with the Postal Service and all the things happening. Maybe there will be a breakdown in that inductive pattern, and we won't see it happen on this occasion. Every president of the United States ever has been a man. So therefore, the next president in the upcoming election will be a man as well. Of course, we already know who the candidates are for this cycle, but we can't say with total certainty that in 2024 a woman will not be elected, even though that would break the historical pattern, because women are in some cases very viable candidates, and Hillary Clinton was very close. But of course, you know, sometimes the inductive pattern, even if it stretches far back into the past, doesn't continue. If prior to the election of Obama, a person had said every president has been white, so John McCain will win the election. Of course, Obama provided an exception to the long-standing pattern, and in that case, we see how induction doesn't always lead us to a correct conclusion. But for the most part, when an inductively strong argument exists, the conclusion is probable. Okay. Now, I want to continue now to add to your vocabulary of concepts a couple of new terms. All right. So we next need to talk about the concept of logical consistency. Okay. Logical consistency. So I'll just get my notes ready here. Logical equivalence, logical consistency. Let's see which order I present them in. Okay, yeah, so let's start with logical consistency. What does it mean for a set of sentences to be logically consistent? Logical consistency. So here's the definition. A set of sentences is logically consistent just in case. Now, the terminology that sometimes is used in providing logical definitions is if and only if. We're going to learn a lot more about that particular phrase in future meetings. It's called a biconditional, and there's a precise analysis to a biconditional. But in English, if and only if is synonymous with the phrase just in case. Sometimes I prefer to use just in case when I'm lecturing and teaching, because I think it maybe has more of a everyday common sense sound to it, to the student. So I'm going to say it that way. A set of sentences is logically consistent just in case it is not, just in case it is possible for all the members of the set to be true, okay? Just in case, sorry, it is possible Okay, so the key to the definition is if it is possible for all the sentences to be true. In that case, it is a logically consistent set of sentences. Quick question, sorry, small digression. I just want to make sure this didn't get left out. We talked about the different types of sentences too, did we not? Interrogatives, imperatives, assertoric sentences. I believe that we did, but you just let me know. Yes, okay, good. So assertoric sentences are the ones that have a truth value. Interrogatives are questions. Imperatives are commands. Exclamations are momentary expressions that give a sense of a person's feeling or attitude. But only the assertoric sentences are used within arguments. Okay, good, just a little review. So back to this. The term and the concept is logical consistency. So what it means is a set of sentences is logically consistent just in case this is the case, just in case it is possible for all of those sentences to be true. Okay, so let me try to come up with some examples of a set of sentences that either is or is not logically consistent. So here's a definition. I'll put it in the chat one time so that it's easy for us to read and see as I go over some more examples. Okay, so now let me erase that since it's in the chat. And let's try to think about that particular definition and give some examples. Okay, so for a set of statements, for a set of sentences to be consistent, it just has to be like logically possible for all of them to be true. Evelyn, I saw your question. You asked about abduction. There are methods of reasoning that we refer to as abduction, but it would take us a little farther afield. So I'm just going to stick with some of the classical deductive methods of reasoning. That's a good question. Okay, so to have a logically consistent set of sentences, it just has to be possible, imaginable for all of them to be true at the same time. Okay, so like take this for example. When we write out sets of sentences, there's a particular type of set theoretic notation which we call bracketing. So you create a left curly bracket like that, and then you list the sentences, separate them by means of commas, and then end the bracket with a right hand curly brace. So let me give you these three sentences. We are in a pandemic. Hillary Clinton is president. And Kobe Bryant is alive. Okay, here's the left brace, and I have three sentences in this set. And then the right brace here is at the end, enclosing the last member. So it's a question for you now. Is this set of sentences logically consistent? Or is it not logically consistent? Let's see if you can give me that correct answer. Okay, Lily, you're saying yes. Very good. Any others? You see the sentences. Alexis also saying yes. Tanya's saying no. Leo, it is. Valeria, no. So let's get into the reasons. For those saying yes, why is it that it is logically consistent? Let us know. Let us give the reasons for your answer. You say it's logically consistent. You've seen the definition. So yeah, good, Leo, exactly. It's because it's possible for all of those things to be true at the same time. Now, are they all true? No. One of the three things is true, and that's the first sentence, that we are in a pandemic. But the other two sentences, for better or worse, they're not true. Kobe Bryant tragically died in that helicopter crash back in January. And Hillary Clinton, as we know, didn't quite get the win in the last presidential election. But these three things could all be true. That means that they are consistent. Yes, rest in peace. So these three sentences, although they're not actually all true, we can imagine a possible world where they are all true. In other words, none of them rules the others out. It's not like one of them being true cancels out the possibility that another one could be true. So they are consistent with each other, okay? They're consistent with each other because there's nothing about one of those sentences being true that is making the others not possible to be true, okay? So that's an example. of a logically consistent set of statements. Hey, Peachy, you guys see, my cat, Princess Peach, right here. So she's trying to chime in and get involved. Good girl. Okay, so let's try another example. Sorry, Peach. I should set you down. All right, so here we go. John is older than Paul. Okay, next sentence. Paul is older than Jane. And then the third sentence, Jane is older than John. Okay, so the three sentences there say, John is older than Paul, Paul is older than Jane, and Jane is older than John. Is that logically consistent or is it logically inconsistent? Let's see if we can figure this out. So some are saying no, that it is not consistent, that it is inconsistent, and that's good, correct. You're exactly right. Let's understand why though. Why isn't it consistent? The sentences that we see here, they can't all be true? Why not? It's something that can be explained. Why is it that it's not consistent? I know it perhaps it's just immediately obvious, but let's just make it explicit. Jane can't be older than John. Well, the right thing to say, Tanya, is not necessarily that she can't be older than John, but that if she is, then of course, he cannot be older than somebody who's older than her. You know what I'm saying? Like, at least have false if the other ones are true. If Jane is older than Paul and Paul is older than Jane, then this third sentence will have to be false. Peachy. If this third sentence is true, that Jane is older than John, then this first and second sentence have to be false. So they cannot all be true together. That's logically impossible. So what we see here is a set of sentences that, taken as a set, they're inconsistent with each other. As you say, Leo, Jane should be younger than John if the first and the second sentence is true. Well, not just if the first is true, because we also need to have that information about the relation of Jane's age to Paul's. Knowing that John is older than Paul, knowing that Paul is older than Jane, the third sentence could not be true. Or if the third sentence was true, then we would have to, like one of these others would have to be false. They're just not consistent with each other. They do contradict each other. Peachy. The cat's going crazy. I don't know what she's thinking. She loves this. This is cashmere, okay? So for whatever reason, when I'm wearing these cashmere sweaters sometimes, it's like she thinks I have fur or something. And she's trying to like literally just rumpus around me. I'm going to put her in the next room for a minute, okay? Sorry. She's crazy cat. She's really cool though. Okay, so yeah, they do contradict each other. So that's one example of logically inconsistent set of statements. Okay, let's see. I'm looking in our book, try and look at a couple of additional cases here. Yeah, so here's another example that's in our book. I'll just read it off. They give this case on page 10. Everyone in the room is left-handed. I could just write this one out. Everyone in the room is, they say, left-handed. Okay, next statement in the set. Mona is in the room. And then the last sentence, Mona is right-handed. Is this consistent or inconsistent? It should be, I think, easy enough to say or see, but you'll tell me. Is that consistent, these statements that are placed within brackets? Inconsistent, says Amaya. Inconsistent, Frida, April, yes, Yvette, and Lily, and the others. You're all correct. It's inconsistent. Why? It is inconsistent because it says, first off, everyone in the room is left-handed. That doesn't mean most of them are or some of them are. The statement everyone, if it's true, means each and every person, 100% of them. So Mona is a person in the room. She's one of the everyones, right? It says after that she's right-handed, but that contradicts the first statement here. So they cannot all be true. If this is true and this is true, then this would be false. Or if it's true that she's right-handed, then either she's not in the room or it's false that everyone in the room is left-handed. You see? So that's an inconsistent set of statements. Now, in everyday life, sometimes people make arguments or they make claims to us, and the information they give contradicts itself. You know, somebody could say, we need to give more money to fund, let's see here. The only way that we can fund our healthcare program is to add money from the budget. And we should do that. But also, I don't want to cut funding for any programs. So that's inconsistent. You're saying we ought to get additional revenue for the program from the budget, but at the same time, we should not cut any specific items out of the budget. That doesn't make sense. If it's the case that we ought to do more, then there's something that we should get funding from. So, you know, like in everyday life and in logic, we sometimes say things that are not consistent. Someone could say, you know, I really love comedies. I love every comedy, but I hate this one movie. That's a comedy. You know, in some cases, it's innocent enough and we're just speaking casually. But sometimes when there's more at stake and when clarity, accuracy is on the line, we want to make sure that we don't contradict ourselves by proffering up inconsistent sets of statements. Okay, so next, I want to continue by adding another term, and this is the last new term for us for today. I might have a chance to go over some special cases of validity also. Okay. And if you look at your homework, for example, I'm just quickly seeing my copy of it here in a different window on my screen. There is a section, questions 16 and 17, that talk about this. And there's also, so I guess there's just a few questions that deal with this in the homework. So based on what we've discussed here, you should be in pretty good position to answer those questions. Okay. So I have another concept to add now. This next one is logical equivalence. This has to do with pairs of sentences. So what does it mean for a pair of sentences to be logically equivalent? Okay, so what logical equivalence means is this. A pair of sentences is logically equivalent just in case it is not possible for them to have different truth values, okay? So if it's not possible for one of them to be true and the other one false. So I'll put that here. Okay, so what is written here says that a pair of sentences is logically equivalent just under this condition, just in case it's not possible for one of the sentences to be true while the other is false. Another way of saying that, which is equivalent, is just in case they cannot have different truth values. So two sentences are logically equivalent if they're logically equal. If they cannot differ in terms of one being true and the other false. So let's try and consider some pairs of sentences to see whether or not they are logically equivalent. Okay. So I'll put this in the chat as well. Okay, so now I'll erase this from the board and give you some examples to think about. Okay. How about these two? So, John is older than Paul. Paul is younger than John. See these two sentences. Question, are they equivalent? Are they logically equivalent? Or are they not? So let me know. Think about the meaning of the concept, look at the example, and then see what you think. Are they equivalent? Yes? Good. Okay. So they are. In fact, yes, that's the correct answer. They're equivalent. Let's be clear about why. Because the information given here is the same information that's given here. So if John is older than Paul, if that's true, then this is true. It's not possible for John to be older than Paul, but false that Paul is younger than John. You see what I'm saying? So like, if this is true, this can't be false. If this is true, this can't be false, right? If this is false, that John is older than Paul, then this has to be false also, that Paul is younger than John. So these two propositions, these two sentences, they can never have different truth values. It's sort of like, you know, Shaq is taller than me. I am shorter than Shaq. Those two statements, one is taking Shaq as the subject of the sentence, and one is taking me. But the relation expressed of taller than or shorter than has been just repeated, merely switching the subject from the one individual to me. So if he's taller than me, then the statement that I'm shorter than him will have to be true. They can't differ in truth values. So like, for example, it's not possible for it to simultaneously be true that he, Shaq, is taller than Vulic, but false that Vulic is shorter than Shaq, right? So the truth of the two propositions must be the same truth value. Okay, now let's give another example. How about this? Alex hates Bill. Bill hates Alex. Are those logically equivalent statements or no? Are those two things equivalent or are they not equivalent? Alex hates Bill. Bill hates Alex. Are those two statements equivalent? That's my question. Right. Okay, good. Exactly. The answer is no. The answer is no because the fact that Alex hates Bill can be true even though Bill does not hate Alex back. Okay? So like hate is an attitude that can be unrequited. It's possible for one of them to hate the other, but not vice versa. So since it is possible for one to be true and the other one not true, they're not equivalent. They don't say an equal thing. Like, they don't say the same piece of information. Saying that Alex hates Bill is not equivalent to saying that Bill hates Alex. And we can see that because of the idea that there's a possible situation in which only one hates the other and not the other way around. Okay? Now, let me see something really quick. Okay. How about this? Okay. Thinking of an example that doesn't sound too similar to the homework itself. John is in the room. The room is occupied by John. Are these equivalent or not? John's in the room. Basically, the second says the room is where John is. Are those equivalent? Yeah, Alexis, I see your joke that they could be, but the fact that it's possible instead of necessary just means those weren't equivalent to other example. Okay, yeah, so in this case, these are equivalent. John being in the room, if that's true, then it's also got to be true that the room holds John, and vice versa. If the room holds John, then John in the room is true. On the other hand, if one of them's false, the other one has to be false too. If he's not in the room, then also the room is not occupied by him. Okay, let me just give you a few others just off of talking without putting it on the board. So Daniel is my brother. So Daniel is the brother of Richard. Sentence 1. Sentence 2. Richard is the brother of Daniel. Are those two things logically equivalent? So the first statement is, he's my brother. And the second statement is, I'm his brother. Yes, those are equivalent because the brother relation is symmetrical. It's not like I can be your brother, but you're not mine in the biological sense, of course, right? So lots of pairs of sentences, if you just evaluate and analyze the information of them, you can make a judgment and correctly determine whether they're equivalent or not equivalent. And once again, if they are equivalent, it's never the case that one of them is true and the other is false. That's just not possible when they're equivalent. They stand or fall together. They've got to have the same truth value. 6 times 2 equals 12, Evelyn, is a mathematical truth. It's logically equivalent to 2 times 6 equals 12. That's correct, yeah. If you switch around the subject and the object of a sentence, you can generate pairs that are equivalent. Like we talked about hate. Alex hates Bill. If I had said Bill is hated by Alex, that doesn't express that he hates him back, but that he is the subject of Alex's hate. And in that case, those would be logically equivalent. So some of it depends on the wording, but the underlying logic is something that can be understood just by reflection. Okay, so let me go on a little bit now. And I need to next go over, if I can, a couple of what are called special cases of validity. Okay, so as we think again about what validity is when the premises of the argument, if they were true, then the conclusion could not be false. So a valid argument is one where it is impossible for all the premises to be true and the conclusion false. Now, I've given you some common sense examples of valid arguments, like all dogs are mammals, Labradors are dogs, so therefore Labradors are mammals. That would be valid because assuming the truth of the premises, the conclusion is logically guaranteed. But But there are also a couple of what are called special or technical cases of validity. And those have to be mentioned as well because they're involved on your homework too. So there's 3 special cases of validity. These are sort of like, in a weird way, like they're just technical cases of validity. They're cases where an argument is valid, but only because of formal rules having to do with logic. Okay, so let me put that on the board. 3 special cases of validity. Three special cases of deductive validity. Okay, so an argument is automatically valid if any of these 3 things are true. Number 1, if there is a premise of the argument that's logically false. Okay. Sorry, this is not the best marker. Let me rewrite this again with a better marker. So that's one case where at least one premise in the argument is logically false. That will render the argument valid by itself, regardless of what the premises and the conclusions say, regardless of what the information is. If there's any premise in the argument that's logically false, bam, like automatically that's just a valid argument just because of that. Now, a second special case of validity is when the conclusion of the argument is logically true, okay? So that is a second special case of validity. If any argument has a conclusion, which is a logically true conclusion, then that by itself makes that a valid argument. And now the third special case of validity is this. If the premises of the argument form a logically inconsistent set. Okay, so the third special case is if the premises of the argument form a logically inconsistent set of sentences. Then that would also make it valid. Okay, so to understand why these 3 special cases of deductive validity exist, you have to remember again the definition of deductive validity. And so by now I think we know that. The definition is that an argument's deductively valid just in case it is not possible for all the premises to be true and the conclusion false. But if any of these 3 things apply to the argument, then it is not possible for all the premises to be true and the conclusion false. And for that reason, it is therefore classified as a valid argument. Okay, so let's talk about the first possible special case here. I'll erase the top part here so I can maybe write a few things above. So suppose we have an argument like this. Here's the premise, and I'm just going to make it have one premise. So the premise is going to say 2 + 2 equals 7. So therefore, the Earth is flat. Okay. So, question. I know it's a weird example, okay? But the question is straight up. Is this valid or not? And keep in mind these three special exceptional cases of validity. So is the argument placed here? 2 plus 2 equals 7, therefore the Earth is flat. Is that valid? Okay, good, Lily. Yes, correct. Who can tell me what the reason is that that's considered to be valid? It has to do with one of these three special cases. So it's valid, and the reason for it being labeled as valid is because of what? Because the premise is logically false, okay? This is logically false. 2 plus 2 equals 7 is false, but it's extra false because it's a false mathematical statement, so it has no potential to be true at all. That's a logically false premise. So just because of that, even though the conclusion is itself false, the argument is valid. It's valid because if this cannot possibly be true, and it's one of the premises, that means that the premises cannot all be true and the conclusion false. Why can't the premises all be true? Because this premise will never be true. So if there's any premise that has no ability to be true no matter what, then that will deprive the argument of having the ability to have all true premises, right? And to be valid, an argument has to be such that there cannot be all true premises and a false conclusion. And the combination TF cannot exist here because this premise will never be true. So it's valid for that technical reason. Even if there were more than one premise. Suppose I have this. 2 plus 2 equals 7. The Earth orbits the sun. Therefore, dogs can fly. This is a weird case of validity, right? Normally with validity, the premises and the conclusion have something to do with each other. Like if I say all people who teach at Cal State Fullerton have got a bachelor's degree. I teach at Cal State Fullerton, therefore I have a bachelor's degree. That's like an ordinary valid argument where you can see the logical link between the premises and the conclusion. In this special case of validity that we're looking at here, you can get the sense that the premises are not at all really relevant to this conclusion, but it counts as valid just on the technical kind of like formal rule basis that when any premise is logically false, look no further at anything else. It's already valid just because of that. So Samir, no, it does not have to be all three. These are three different cases of validity that are special, but they can mutually overlap. There could be an argument where a premise is logically false and the conclusion is logically true, and then it would satisfy both requirements. But it only has to satisfy a minimum of one of these three to be a special case of validity. So that is a good question. Okay, now let me add another example to this. But again, just looking at this one more time. In this case of these arguments, or this argument rather, the second premise is true. The conclusion is obviously false. But the first premise, since it's logically false, that means that we will never have the combination TTF. This will always be F. And therefore, if it's not possible to have all true premises and a false conclusion, it satisfies the definition of validity. Okay, let me give you another example. All right, so the argument, okay, so Trump is the president. Let's see. Sacramento is the capital of California. Therefore, a square has four sides. So you see the argument there. Premise one, Trump is the US president. Premise two, Sacramento is the capital of California. Therefore, a square has four sides. Now, is that a logically valid, is that a deductively valid argument, this new example? If you can see the argument and you see these associated statements, yes, correct, that's right. Now, who can say why this argument is labeled as deductively valid according to our 3 special cases of validity? This is valid, and the sort of technical reason is because, yes, exactly, Lily, the conclusion is logically true. The conclusion is a logical truth about the number of sides found on the 4-sided square polygon. So because this is logically true, it doesn't matter what information was up here. This could have said dogs can fly, Hillary Clinton is president. Therefore, a square has 4 sides. As long as the conclusion is a logical truth, the information written above is totally irrelevant, and it's considered valid on that basis alone. Because again, if the conclusion is logically true, then that means that it's not possible for the argument to have all true premises and a false conclusion, because having a logically true conclusion prevents it from ever having the false conclusion. If an argument cannot have all true premises and a false conclusion, it's valid. And it can't have all true premises and a false conclusion if the conclusion can't be false in the first place. So another special case of logical validity. This conclusion could have said something else that's a logical truth, like 2 + 2 is 4, or the brown dog is brown. Whenever a conclusion is logically true, say no more. It's a valid argument. Okay, so I just want you guys to be clear and understand that as well. Okay, so one more case, a special case of validity to reveal a few examples. Okay, so let's look at this next argument. Let's see here. So I just wrote this argument. It says Bill is taller than Ted. Okay, Ted is taller than Bill. Therefore, the sky is blue. Is this considered valid? And if so, or if not, why or why not? This new example. Bill is taller than Ted. Ted is taller than Bill. And therefore, thus, hence, the sky is blue. What can you tell me? Is it valid? I see a few of you already saying yes, and that's correct. It is. This illustrates the third sort of special case of validity. Why is it valid? Let's say why. Because the premises are logically inconsistent. They contradict each other. No, it's not because the conclusion is logically true, actually, Alexis, because though the sky is blue, there could have been a different hue to the sky under a hypothetical different course of world or universe history. But the reason that it's valid is having to do with this one. Because the premises of the argument form a logically inconsistent set. These two statements can't both be true because they're saying opposite things. This says he's the taller, and this says no, the other guy's the taller. Two people can't be taller than each other. I hope that is immediately obvious. So these two things cannot both simultaneously be true. They cannot both be true at the same time, so they're inconsistent. Since they're inconsistent, the argument's valid for the following reason. Validity, once again, just means it's impossible for all the premises to be true and the conclusion false. And if we have an argument whose premises are inconsistent, then that means they cannot all be true. Given the definition of inconsistency, the fact that they are inconsistent means that they cannot all be true. If they can't all be true, then furthermore, we can't have the argument there where all the premises are true and the conclusion false. The mutual inconsistency of the premises in that case eliminates the possibility of all the premises being true, and thus, in addition to that, it eliminates the possibility for all the premises to be true and the conclusion false. Knowing that it can't have all true premises and a false conclusion is enough to know that it's valid. Okay? So like when you look at the homework problem set, there are definitely questions that involve these distinctions. For example, it says give arguments with the following characteristics. And then it says, where possible, give an example of each of the following, and where not possible, explain why no example can be given. So you'll have to like use your knowledge of the lesson today to say, for example, question 8, a consistent set with at least one true member and one false member. You have to be able to create an argument which has those features, or sorry, a set of statements that has those features, if it's possible. And if it's not possible to do that, then you'll have to say why it is impossible. Let's see. Yeah, so I mean, I'll take further questions as you guys start to work on the homework. I know it's just been distributed to you, but I think that as you develop the answers and stuff, you might have a couple of questions involving some of these topics here. But that's really the main basis of today's lesson that I needed to cover for you guys. Talking about what is logical consistency, what is logical equivalence, and these 3 special cases of validity. That's the main new material that we've added to our notes for today. So understand that validity in the ordinary case is when a conclusion is something that follows logically from the premises. You know, I'm bigger than my cat is bigger than a snail, so therefore I'm bigger than a snail. That's a valid argument, and it makes sense because there's a logical relevance of the premises to the conclusion. But there can be these 3 technical cases of validity. And in cases like that, as you can see, the argument could appear kind of weird because the conclusion may have little to do with the premises. Jamie, where do we turn the homework in? Just you'll submit it to me as an attachment through email. Anytime before 11:30 a.m. on Wednesday the 16th. So you have a full 2 weeks to do it, not to rush. I would say take your time and make sure you're confident in your answers. And you can always check in with me if you have any questions about the material that you're doing when you do the homework. But yeah, you just submit it to me as an email and attached file. Okay. So like on page 11 and 12, section 2 of the practice problems, they ask you to try and put these passages in standard form if there's an argument in the passage. So, like for example, question A says, when Mike, Sharon, Sandy, and Vicky are all away from the office, no important decisions get made. Mike is off skiing, Sharon is in Spokane, Vicky is in Olympia, and Sandy is in Seattle, so no decisions will be made today. That is an argument which is just being written out in everyday English. So if you wanted to do that practice problem, all you would have to do, that's for your own like knowledge and review, try to put it in standard form. So in the case of that argument, the conclusion is the last sentence, so no decisions will be made today. That would appear at the bottom. And then you would simply list out the different premises above that so that it can be displayed in the formal way of logic. Some of the passages, though, in the problems that are given as practice problems there do not have any argument at all. Like this one says, Humpty Dumpty sat on a wall, Humpty Dumpty had a great fall, all the king's horses and all the king's men couldn't put Humpty together again, so they made him into an omelet and had a great lunch. None of those things imply a conclusion. So it's just a sorted set of facts, but none of them is reasons for any other. And that's important to know the difference. I'll just close with this. Not every random set of sentences is an argument by itself, unless there's some type of inference that has been made. If I tell you about the contents of my backpack, like I say, in my backpack right now, there's a textbook, there's markers, and there are student essays. Is that an argument? No. It's a bunch of true statements, but none of them is a reason for any of the others. So you have to be capable of understanding when the presentation of certain facts and information amounts to an argument. And the key giveaway is when you hear or see words like therefore, so, thus, or hence. In the absence of such words, it may just be that the person is stating a bunch of facts, but that don't have any logical connection to each other. All right, guys. Well, we've covered some good ground today. I feel confident and good about what we've done. Let me know over the next weeks and days If you have any other questions, Yvette, just to confirm, we only have to turn in the homework that was posted. Correct, yes. The exercises listed in the syllabus are just for practice. The actual homework is like going to be sent to you via Titanium announcements like I did today. And there's 4 different batches of homework problems. So you guys are now going to get started working on the first one. And the second one I will give later on before the midterm. And the third and fourth, they will happen after the midterm. Okay. So anyways, thanks everybody. For now, I guess we're good to go. Have a great day. Hope you guys have a good Wednesday. And I'll see you guys back after the long break. So next Wednesday, the 9th, we will resume. Okay, guys, and I'm happy to take any questions in the meantime through email or office hours or whatever it is. So have a good one, and I'll see you guys next time. Bye-bye. Thank you. Thanks.